Hello children, welcome back to my channel. The chapter is Quadrilaterals for standard 9. This is part 11. So in the earlier parts we were doing problems related to the properties of the quadrilaterals. All the properties also we proved and few questions related to that. Now here we are going to start with a new theorem, midpoint theorem. It's a very important theorem which is very often asked in exams, and we will be doing some questions also related to the theorem. The theorem says the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. That means D and E are the midpoints of the triangle. This D and E are the midpoints. Then DE will be parallel to BC and DE will be half of BC. So, we will prove that theorem. The proof is also important. So, for this we have to do some construction, that is we have to produce DE such that DE is equal to EF. These two are equal. Now, D is the midpoint, so these two are equal, and then E is also midpoint, so these are equal. So, now we will consider this triangle, this one and this. So, consider triangle ADE and triangle FEC. So, we will start with DE equal to EF side by construction. Then angle 1 equal to angle 2 A, vertically opposite angles, and then AE equal to EC. Given even E is a midpoint. So, therefore, triangle we started with DE. So, we will start with DEA is congruent to triangle FEC SA's criteria. From that we can say AD equal to FC. So, we got AD and FCS equal. And then ADE, angle ADE, this is ADE, CFE. Let us check in the diagram where is ADE. It is here. We will put this as 3 and this as 4. Both are CPCT. Since 3 equal to 4, so you are able to draw, the figure is like this, 3 and 4. That means you can say these two lines are parallel. Therefore, AD is parallel to FC. The reason is alternate interior angles are equal. Now, since AD is parallel to FC, you can say therefore AB is parallel to FC. That means you can say BD is parallel to FC. Keep this as 1. Now, we have proved AD equal to FC. That means you can say AD is equal to BD, BD equal to FC. So, from 1 and 2, you can say now you got BD is parallel to FC and BD is equal to FC. Therefore, BD FC is a parallelogram. You have done this many times. The same side is parallel and equal, the same sides, that is the same pair of opposite sides are parallel and equal, then you can say it is a parallelogram. So, therefore, you can write DF is parallel, therefore DF is parallel to BC. Opposite sides of a parallelogram are parallel and equal. DF is parallel to BC, therefore DE is parallel to BC, and DF equal to BC. So, DF is equal to BC, DF can be written as twice DE, because E is the midpoint of DF by construction. So, twice DE equal to BC. The reason E is the midpoint by construction. Therefore, DE equal to half of BC. So, DE is parallel to BC and DE is equal to half of BC. So, it is a very important question. So, practice it 2-3 times. Now, the converse of this midpoint theorem is, if one of the midpoint is given either D or E and it is also given D is parallel to BC, then you can say the other point is the midpoint. That is, if D is the midpoint given and D is parallel to BC, then E is a midpoint. Yeah, the basic problem or question we will do. Show that the line segment joining the midpoints of the pairs of consecutive sides of a quadrilateral is a parallelogram. So, given ABCD is a quadrilateral and P, Q, R and S are midpoints. You have to prove PQ RS is a parallelogram. So, consider the triangle ABC, P and Q are midpoints. Therefore, PQ is parallel to AC and PQ equal to half of AC. Let me the equation 1. Consider the triangle ADC. S and R are midpoints. Therefore, SR is parallel to AC and SR is equal to half of AC. So, from 1 and 2, we can say PQ is parallel to SR and PQ equal to SR. Therefore, PQ RS is a parallelogram. Now, suppose the question given is, show that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. That means you have to prove PR and SQ bisect each other. For that, first you prove PQRS is a parallelogram, and then you can say PR and SQ are the diagonals. You can say PQ, since PQRS is a parallelogram, prove it and say PR and SQ are diagonals. Therefore, they bisect each other. The next question is, show that the quadrilateral formed by joining the midpoints of the consecutive sides of a rectangle is a rhombus. So here given ABCD is a rectangle. Then PQRS are midpoints. You have to show it is a rhombus. Prove PQRS is a rhombus. So the first thing for all proofs similar to this, first you have to prove PQRS is a parallelogram. We have already done the proof earlier. So follow the same steps and you have to first prove PQRS is a parallelogram. So this is mandatory for all the first, the quadrilateral has to be a parallelogram. Then you will prove, then you have to prove it is a rhombus. To prove it is a rhombus, if you prove the adjacent sides are equal in a parallelogram, it is a rhombus. So we will see how to prove it is a rhombus. Here there are two methods. One method is using the midpoint theorem, another is using the congruence. I will teach you both. So whichever is easier for you, you can use, but I always prefer the midpoint theorem. Since you have learned midpoint theorem, it is much easier, you can use that. So first, using the midpoint theorem, in triangle ABD, PS is parallel to BD and PS equal to half of BD. The reason is P and S are midpoint. You have to write all the reason. P and S are midpoints. Midpoint theorem. Then in triangle ADC, you have to prove the adjacent sides are equal. So you will take the adjacent portion only, that is the wherever the adjacent side is there, that triangle you have to take. So triangle ADC, you have RS as the adjacent side. So RS is parallel to AC and RS is equal to half of AC. The reason is R and S are midpoints. Midpoint theorem. So now rectangle, you know the property of the diagonals of a rectangle. In a rectangle, the diagonals are equal. That is AC equal to BD. AC equal to BD. So here BD is, PS is equal to half of BD means BD is equal to 2 PS. And here AC equal to 2 RS. So here you will write AC is equal to 2 RS equal to BD is 2 PS. From 1 and 2. Therefore, RS is equal to PS. So you got the adjacent sides. This RS is equal to PS. In a parallelogram, adjacent sides are equal. If adjacent sides are equal, it is a rhombus. Now the second method, I will draw the figure again. Okay. So here congruence method. So you will take the triangle, consider the triangle SAP and triangle SDR. So we can say, you know, DC is equal to AB because it's a opposite sides of a rectangle. Okay, I will write it here only. DC is equal to AB, opposite sides of a rectangle are equal, and then therefore half of CD is equal to half of AB. Half of CD is what? You can take it as RD is equal to half of AB, you can take it as AP. Leave it. Similarly, AD equal to BC, half of AD equal to half of BC. I write the step fully. AD equal to BC. So half of AD equal to half of BC. So half of AD, you can take it as SD. We can take it as SD. Here no need of AD equal to BC. It is the same side that we are taking. So sorry. Now here SD equal to AS. Yeah. So we will consider the triangle SAP and SDR. Now you have AS, SAP, AS is equal to SD side, S is the midpoint. So this is equal to this. Now it is a rectangle, so these angles will be 90. Angle SAP is equal to angle SDR because ABCD is a rectangle. All angles are 90. And then you have AP equal to DR from 1. We have already proved that. Therefore, triangle SAP is congruent to SD or SAS. Therefore, SR, SDR, SAP is equal to SDR. So SP equal to SR. SP equal to SR. CPCT. So again, write down the same thing. If the adjacent angles of an parallelogram are equal, then it is a rhombus. Hope it's clear. So you can use either of the method. So the first method you have to use, you should know the properties of the quadrilaterals. So the second method is using the congruence. So you can follow whichever method your school is asking you to do, or you can check with your teacher whether you can follow either of the methods. See you again with more questions in my next video. So till then, keep practicing and please practice the midpoint theorem. And till then, bye and have a nice day.